Okay, chapter 8, section 3, it's similar polygons. All right, before I hand in the air, I want you to remind the neighbor what polygon means. Ready, set, tell your neighbor, what's a polygon? All right, hold it. Hands in the air, hold up 2 fingers and wiggle your 2 fingers. Polygons, you can split it into 2 different words. Poly. Hand in the air. Does anybody remember what poly stands for? Allie, do you remember? Many. Poly means many, more than one, like Moot said. Gon, G-O-N. Does anybody remember what gon means? Allie, keep going. Sides. Many sides. So we're talking about any shapes that are similar. I have like ghetto versions up on the board. They are similar shapes. One's small, one's big. What you need to know, which is super killer in this section, all angles always have to have a match in the other one. Sides are proportional. That means they're not congruent. Hopefully that's obvious to you because one's small, one's big. But the angles always have to be congruent to an angle and the other one. Okay, so there's polygons. 4 vocab words. If you look in your notes, you only have 2. We're going to add 2 more after that. Okay, remember, these are your notes. You don't have to write word for word. I just want you to understand. Similar polygons, what I just barely told you, super important that you remember this. Corresponding angles are congruent. They are exactly the same measurement. If you have a 30 angle in one shape, you should have a 30 angle in the other shape. Literally exactly the same. Okay, the second killer thing you need to know about similar polygons is that their corresponding sides are proportional. That's what we did on our warm-up today. Something over something equals something over something. Sides aren't equal because one's small, one's big. Angles congruent, sides proportional. Okay, are you ready? Let's get some shouting going on. In similar figures, angles have to be what, guys? What is it? What? That's the most pathetic shouting I've ever heard. Corresponding angles are what? Congruent. Nicely done. Corresponding sides are? Proportional. Perfect. Perfect. All right, scale factor. This one, I hope it's pretty straightforward. Scale factor is the ratio of one length compared to the other length. If this word makes you nervous, don't let it. Ratio is just a fraction. Compare this compared to this. Something over something else. Okay, you might want to turn your notebook sideways for the next 2 vocab words. Okay, similarity statements come up later, and so do proportionality statements. And I want to make sure you know the difference between the 2. The similarity statement, let's just write an example. I want you to see what it looks like visually. Similarity statement would be like this. A, B, C, D is similar to E, F, G, H. That is a similarity statement. The little squiggly means similar. Just saying this shape is similar to this shape. That's an example. That's what a similarity statement looks like. All right, well, proportionality statement. Again, this is like what we did on the warm-up, where we said pesos over American dollars equals pesos over American dollars. So this one, I actually taught it to you, but it's been a while. You can match it up perfectly. So it would be side AB over side EF. That's our first proportion. But you have to finish it. You have to do all sides. So that would equal side BC over FG, which would equal side, keep going, CD over GH, which would equal, okay, let me know the last one I'm missing. Perfect. The first and the last. So it would be AD and EH. This whole thing with all sides written as a proportion is a proportionality statement. What is that called, guys? Way to mumble. Proportionality statement. If I just ask for similarity statement, you just put the little squiggly. This is similar to this. Okay. Let's keep rolling. So there's our 4 vocab. So here's our first question. We have to say, yes, this is similar, or no, it's not similar. First test is always check the angles. So right here, this has 3 markings. is there an angle from the other picture that also has 3 markings? So we're good. What about this one? 2? 2 and 2 markings. This one, how many? 4 and 4. We good? 1 and 1. All right, so it passed the angle test. Now you've got to do the side test. But are sides equal in similar figures? No, because one's bigger, one's smaller. So set up a proportionality statement. So right here, if I said side FG, what would FG correspond with? Perfect. So we can write that just as a fraction. So that's 8 over 6. But you have to check all sides. So you've got to see if that equals this one. Does that equal 16 over 12? And does that equal, I'm just going to keep going in a circle, 15 over 20? And does that equal the last 2?
Wait, isn't that one upside down?
Yes, you got it. It matters. So I put 15 over 20, but it needs to be what? Uh-huh. Okay, it's a good catch. So last one is going to be what? 12 over 9? Okay, what I was going to encourage you to do is cover up all of your denominators. Whether you just put your arm on them or your pencil if you write little. And make sure all the numerators come from the same shape. Do they? Okay, then you're good. You've got a good setup. Same denominator should all come from one shape. Okay, now as far as figuring this out, it depends what kind of person you are, what kind of math life you have. Are you a fraction person or are you a decimal person? Because you can figure it out either way. If you're a fraction person, you just simplify it. So let's figure it out first for our fraction people. So right here, 8/6, just simplify it. What goes into 6 and 8? 2, so 8 divided by 2 is 4, right? 6 divided by 2 is 3. So simplified, this is 4/3. Okay, 16/12. What goes into 16 and 12? So that would be 4/3 again? Okay, so we're good so far. All right, 20/15. 5. Was it still 4/3 then when we divide by 5? Last one, 3, right? So 12 divided by 3, I think it works. So what do you think about that? Is that shouting yes, similar, or no, not similar?
Yes.
It's saying yes because they all have the exact same ratio to the sides. Okay, but maybe you're not a fraction person, you're a decimal person. Everybody grab your calculators. Okay, for my decimal people, you can make this really nice for yourself. Because fractions are really division problems in disguise. My 7th graders are like, what? But it's true. This line just means what? Divide. So grab your calculator and just do 8 divided by 6. The 3 repeats? Alright, I'm just going to put 1.3. Okay, do the same thing. Do 16 divided by 12. Okay, do you agree it's going to be 1.3 for everyone? So whether you're a fraction person or a decimal person, there's 2 ways you can solve it. You'll get the same answer either way. So just decide which you would prefer and go for it. Thumbs up. How many like, I got that? Does that make sense? Okay. Let's look at our next one then. Okay, this one. Decide whether they're similar. Same thing as before, and then we write a similarity statement. Oh, shoot. Yes! Sorry, go back to this one. Similarity statement. Let's just go clockwise. So FGHJ is similar. Where's F? So it's got to be the K, L, M, N. That's our similarity statement. Don't get that one mixed up with proportionality statement. Proportionality is like the deep breath. Here we go. Takes a while to write. This one, just make sure you go clockwise. Okay. On to the kind of nervous. Because first, you should check angles. Looking at those angles, are you nervous? I only see one match. So that's like a big, huge red flag. Well, let's check the sides just to be sure. So right here, if I said AB for 8, what would you guys say? Oh, so let's make it a fraction. 8 over 7. All right, we've got to see if that equals this one to this one. 6 over 5. Let's see if that equals the last one. 12 over 11. I don't know about you and your math lives, but I rush your problems and I make mistakes. I think we all do. So same as before, cover up the numerator. Make sure the denominator is all from one shape. Is it? I think we forget about it. Okay, these ones, fraction people, I'm sorry. Can we simplify these? Nope, I'd say become a decimal person just for a little bit. Grab your calculator and just type it in. 8 divided by 7. It's probably 1 point something. 1.14? Okay. 6/5, that's 1 and a fifth. So 1 point, uh-oh. Do we really need to go any further? Is this shouting yes similar or no not similar?
No.
No, it's not similar because those decimals literally have to be exactly the same. Now be very careful. What if we could have rounded this to 1.2? Then would they have been similar? You can't round to make them similar. They literally have to be the same. So right here, not similar. And not for me. Okay, let's see what's next. Oh, the picture problems. Heads up. I would almost put money on the CRT that you're going to have a question like this. They love picture problems. You just got to set up this over this equals this over this. So the bottom of our little picture is 4. What's the bottom of our big picture? So let's make that our first fraction. 4 over 26. Go back to the little picture. 6 over x. Okay, grab your calculator, solve it. Oh wait, tell a neighbor what'd you get? Alright, tell me what'd you get?
39.
Okay, great. 39, and did they tell us inches? They did. 39 inches. How many of you I got that one? How many of you are like, give it to a CRT, we'll get those ones? Yeah? Just remember, match up the sides. Okay. Alright. Oh, this one, I already kind of gave this one away. So this is proportionality statement. So you can break it down into pieces. KL over PQ equals L over QR. So go for it. I know you're copying it down. Take your time. Okay. Now that you've got it down, what I really want you to take away from this, because I think you've pretty much got the idea of the proportionality statement, we've done it before, is this idea of the ratio of the perimeters. Technically, you don't have to add up every side and then add up every other side and then simplify. The ratio of the perimeters, you can just take one of the sides and compare it to the other, simplify it, and that's the ratio of the perimeters. It's always the same. So compare 8 to 10, simplify it, what would it become? Right there, that's the ratio of the perimeters. It works every time. You can add it up one shape, add up the other shape, and then simplify. You'll get the same thing. So it's just like a shortcut built in. Okay, here we go. Example number 3. Practice first, similarity statement. Do you know what that looks like? Practice it, practice it. So similarity statement, you gotta be very careful. I'm gonna go clockwise. I'm gonna say C, D, F, G, H. Alright. So shape, polygon, C, D, F, G, H is similar to, so it's kind of tricky because it's flipped. So C corresponds with J. I know at least that much. But then what matched the D? Oh, the K. So it looks like we're going this way. So J, K, L, M, N. J, K, L, M, N. Alright, how many of you, I see that. Do you see even though it was rotated, flipped around? Okay, proportionality statement. Deep breath and go for it. I want it in letters first, and then we'll set up to solve it. Practice the proportionality statement. Okay, I'll do it up here if you need help. So that would be CD over JK equals next one DF. Curious, how many beat me? Nice. Alright, proportionality statement. So just for practice, those are the differences. I want to make sure you don't get confused. Similarity statement, proportionality statement. Okay, from this, we can set it up. You probably could have done it without the proportionality statement, but we've got to use the one that has CD in it. CD is on the board, and the one that has DF. Oh, right next to each other. How convenient. So instead of putting CD, what can we put, guys? X. Instead of JK, what can we put? Perfect. Okay, it's my 2 again. All right, DF, what is it? Over KL, 6, because you can do this on a calculator. What's 9 times 2? Divided by 6. There you go. So X is going to be 3. Curious, how many are like, I got that. You okay? All right, same thing on the next. Practice the similarity statement. It's nice because it's only a triangle. Same, do the proportionality statement. It's nice, it's only a triangle. And then solve it. Try this one on your own, please. All right, this one, I get nervous for similarity. I just start with one of them and I go for it. So I'm just going to say P, R, Q is similar to, all right, and then I have to pay attention to the other one. So I look at P, and I just look at the notations. P had the one little arc, so what from this one has one little arc? So it has to go V, and then I went R. R has nothing. Which one has nothing? So it'd have to go V, S, T. How many of you have exactly the same? The exact same? How many of you have a different similarity statement? Okay, is that okay if yours is different? Absolutely, but it still should have P and V in the same spot, R and S in the same spot, Q and T in the same spot. Okay, and then when it comes to proportionality statements, I taught this to you a long time ago. I get confused by the pictures, so I just look at this, and that's how I set it up. So I think, all right, P and R first, so it'd be PR over VS, R then Q, so it'd have to be S then T, and then P, Q first, last, VT first, last. How many of you, I got the same thing? Maybe a different order, but the same thing, we good? Okay, now here's what I just barely told you. You can shortcut this. If it asks for the ratio of the perimeters, yes, you can add them all up on one, add them all up on another, and then simplify, or compare one side at a time. Let's just do the PQ and the VT. Where is it? PQ is 9, VT is 6. All you have to do is simplify 9/6. What do they both get divided by? 3, so that would be what? There you go, that's the ratio of the perimeters. Trust me, it's a shortcut. If you want to, you can test it. Add up all of one shape, add up all the other shape, and then divide them, simplify them, you'll still get 3 halves. It's a great shortcut. Okay, try this. Oh, I was just reading the directions, and I would say the directions gave it away. So I'm not going to worry about having to match it up. They already lined it up for me. J, K, L, M is similar to P, Q, R, S. They just wrote out in a sentence, and that's our geometry notation. How many of you exact same similarity statement? Cha-ching. Okay, proportionality statement. How many of you are like, I'm confident with that? Do you know how to set those up? We good? Okay, let's just solve for it then. So that would be, you could do 20 over 15 equals 8 over x. Yikes. What's 8 times 15? 120? 120 divided by 20, what is it? 6. Nice. How many of you got that? You feeling okay about this?